Inter-VLAN routing extraordinaire. What would a switching course be without bringing some routing into the picture? It'd just all be layer 2. That's it. Nothing would move between VLANs. And that's what we're going to talk about here. We're going to look at ways to move traffic between different VLANs. We'll look at the first mechanism, the famous router on a stick. Then we'll move into multi-layer switching, some of the advantages of using a multi-layer switch, and then the actual configuration. Well, let's start this video off as we do with most, a dilemma to be solved. We've talked all about VLANs up to this point and set up VLANs between our switches, but now our clients need to get between VLANs. The VLANs by design have isolated them into their own subnets to segment the networks, segment broadcast, put up security boundaries, but there is times where we need to route between those VLANs. So what are our solutions? The first solution to this dilemma is one of my favorite technical concepts to talk about because of the name, a router on a stick. Reminds me of a corn dog. But this router is a router with a fast Ethernet or greater interface that has a trunk configuration set up to the switch. Now the switch is going to send it all of the VLAN information, as trunks do, across that trunk line, and the router is going to have more than one IP address assigned to the interface using sub-interfaces. And we'll talk about that in the next slide when we get into the configuration of this. The advantages of using a router on a stick is it's very simple to set up. You can use your existing equipment, and it's a lower cost because you don't have to have any special switch hardware to do this. It's all on a router, which you typically have connecting to your WAN interface anyway. Now, the disadvantages of this config is, number one, you can have congestion on a link, especially if this is not a multi-layer switch. Again, we'll talk about that as we expand on some of the hardware that the modern switches come with. Because every single stream or conversation that's coming from this VLAN goes into this switch through the router, back out, loops around, and out the other VLAN. So you're really eating up a full duplex connection because the traffic goes in and comes back out into the switch. Now, a multi-layer switch can ease that load greatly on the router, but still, the congestion on that link can be one of the worries you have to think about. Second is that you have a single point of failure, meaning if that router goes down, you lose all of your routing for all of your VLANs. So the alternative is to set up a redundant router on a stick, which can end up being pointless because of the style of connection that it is. It's essentially wasted equipment. Finally, the delay of routing. And this is something we're going to discover when we look at the solution number 2. Routers, compared to switches, are very slow. Even though it feels fast as we're going through the router, surfing the internet, and that sort of thing, it just can't hold a candle to a switch, which does all of its movement of packets through the hardware. So comparatively speaking, a router on a stick is the slower solution. To set up a router on a stick, there's really 2 steps. Number 1, we need to configure a trunk on the switch that's connecting to the router. And you can see I have fast Ethernet 0/1 on this switch plugged over to the router. That needs to send all VLAN information that direction so that the router can route it. Step 2 is to create sub-interfaces on the router and assign them IP addresses that respond to the VLAN that they belong to. So let's go ahead and work through these steps on live equipment. I'm going to bring up a switch right now. I'm going to go into interface fast Ethernet 0/1, and I'll do switch port, trunk encapsulation, and depending on the router and iOS version you're using, you can use either 802.1q or ISL. Cisco is trying to make ISL go away, so let's stick with their world and just do 802.1q. I'll then type in switch port mode trunk. Enter. That's now hard-coded as the trunk port, and I can go back here and do a show VLAN. I'm going to make sure the other pieces of the puzzle are in place. I've got VLAN 10 and VLAN 20 turned on right now, and they are a part of Fast Ethernet 11 and 12, which reflects our diagram right here. Host and VLAN 10, host and VLAN 20. Now, just glancing at this config over here, the subnet I chose for VLAN 10 is 10.1.10.0 and 20 is 20.0. So that's the switch side of it. Now, once Fast Ethernet 0/1 negotiates a trunk, it will disappear from this VLAN list and not show up because trunks don't appear in the VLANs. I'm grabbing my console cable and switching it over to the router. There we go. I'm on my router on a stick right now, and I'm going to go into global config mode, interface fast Ethernet 0/0, and type a command that we're all familiar with and done many times, I'm sure. No shutdown. I'm typing that just to make sure you guys catch that that's all I do under the physical interface. If I were to assign an IP address to the physical interface of this router, it would be responding for VLAN 1. Now, Cisco's recommendation says try not to use VLAN 1 on production networks. It's just more secure that way because everybody assumes most things are a part of VLAN 1 if you're an intruder of some sort, and there's a lot of vulnerabilities with that. So we'll stay away from that, not assign an IP address to the physical interface. I'll just go directly in. Oh, look at that. Duplex mismatch. I'm going to go in and type well, let's go with half, just to fix that duplex mismatch for now. All right. So I'm going to go into fast Ethernet 0/0 dot, and this is how we create a subinterface. I'll do a question mark. We can have up to 4,294,000,000 da 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 da, some number of subinterfaces. Now, if you actually had the motivation to create that many subinterfaces, the router, I'm sure, would run out of memory before you got there. The reason they give you that many numbers is because they want to give you flexibility with what you name it, so you can do logical names for yourself. Now, in our case, this subinterface is going to route for VLAN 10, so I'm going to put .10 after that and create that subinterface. Now, I didn't have to do that. That was just a logical term for myself. I could create any subinterface number I want to. I could have made subinterface 100 route for VLAN 10 because the key command that links this to VLAN 10 is typing in this encapsulation .1q 10. Enter. At that point, oh, it's telling me I typed things out of order, but that's saying to that subinterface, you will respond for VLAN 10. Now, it's mentioning that if the interface doesn't support baby giant frames and the maximum transmission unit has been reduced and all that, what that's trying to say is it's now going to insert the tag into that subinterface. So if the interface on the other side isn't expecting that, you're not going to get any connectivity. Now, some routers, you have to type in the IP address, or I'm sorry, the encapsulation before you assign the IP address, otherwise it will reject it. So I'm going to say on this subinterface, the IP address is 10.1.10.1. Oh, let me get my 10.1.10.1. Excellent. I'm going to then exit out and type in interface fast Ethernet 0/0.20. Do the same thing here. Encapsulation .1q20. Enter. And I'll type in IP address 10.1.20.1. Good. At this point, I can do a show IP interface brief, and I'll just include fast Ethernet interfaces. And you can see right here I have an unassigned IP address on fast Ethernet 0/0, .10 and .20 have been assigned those IP addresses. We should be good to go. Now I just need to go to my hosts and set them up for that. So let me pause the video. I'll go over to these hosts and configure them with the correct IP addresses. And then we'll just do some trace routes to make sure we're going through the router. All right, the machine I'm recording on right now is this PC right here in VLAN 20. I've assigned it the IP address 10.1.20.50, and I've assigned this PC over here, it's a Dell laptop, 10.1.10.50. So that's going to be the remote host. So let's bring up my command prompt, and I'm going to do a ping 10.1.20.1. And right there, we're getting there. And actually, you know what, let me do a trace route. I always add the -D option because otherwise it tries to resolve host names and just takes forever. So I'll do a trace route, and sure enough, it's directly connected. You can see 1 millisecond right there. Let's go to and that by the way is the router on a stick interface that we're reaching. Now let's go step by step. Let's see if we can reach 10.1.10.1 on the other side. Excellent. You can see just one hop away, and I'm scrolling off the bottom of my command prompt here. There we go. So 10.1.10.1, and let's step it up one more to 10.1.10.50, which is my laptop over there on the other end. So there's 20.1, it's going through the router and reaching 10.1.10.50 over on the other side. So our router on a stick solution is working, but as I mentioned, this is the slower of the solutions. We're having to leave the switch, go to the router, loop back around, be processed by a router in the middle, and then come back into the switch. So let's move on to solution number 2. Now, solution number 2 is where we take a router and smoosh it into the switch. Literally, inside of the switch, if we look inside, there is a router board that is capable of doing layer 3 processing. Now, the advantages of doing this, you can see right on the screen, is you route at wire speed. Now, there's a catch to that, and I'll talk about that in just a moment, but they have a method of moving a lot of the stuff that happens in the iOS software, a lot of the routing pieces, into the hardware of the switch, and that's what allows it to happen. I'll show you how in just a moment. Second is that you have the backplane bandwidth as your limiting factor. Remember when we had the router on the stick, we actually had this external router right here. Obviously you remember, it was previous slide, that we had to leave the switch onto the router. Now this interface right here was the bottleneck because we'd have to go out and come back in on that same interface, which is typically 100 meg per second. Well, since we never leave the switch, since the router's inside of it, the backplane of the switch is the bandwidth, which is gigabits per second on tap. The backplane is the whole circuit board, if you will, of the switch. Likewise, we have redundancy enabled, meaning if we have multiple multi-layer switches, which most people do if they have a enterprise that's capable of supporting multi-layer switching in the first place, we can have one switch take over for another. Likewise, if you have, for instance, say a 6500 or 4500 series switch, you will typically have redundant supervisor engines and redundant, it's known as multi-layer switch feature cards or MSFC cards sitting on top of there. So if one supervisor goes down, then the other one can take over for it. So all good things. Disadvantage, you can see it right there, is cost. Just to give you, this is modern day ballpark figures. Say a 2950 switch with no layer 3 support, you're probably looking at maybe, I don't know, 300, 400 bucks or so for a 24 port switch. For we'll say a 3750, which has layer 3 support, you're probably looking somewhere in the range of $5,000. I kid you not, on the low end. So just to add that router inside of the switch is a big deal. Now the good news is not all switches need to support this. Before I dig any deeper into that, let's get into the how behind this. Multi-layer switches support routing capabilities in one of two ways. The first and the more common way is through something known as SVIs, or Switched Virtual Interfaces. Essentially, these take the place of the quote-unquote router on a stick. They are the routers inside of the switch. And you can see I kind of diagrammed them here as just these little interfaces hanging out of the switch. But remember, there is no physical interface. When I create SVI 10, you're going to see that there's no physical port that it relates to. All I've done is I've created this mystical interface that all ports assigned to VLAN 10 can reach. So when I create this SVI 10, this PC will be able to reach it provided I give that interface and IP address in the same subnet as VLAN 10. Same thing with SVI 20. When I create that, VLAN 20 hosts or ports assigned to VLAN 20 will be able to reach that. So let me show you how that's done. I'm going to go to the console connection of my switch. Got my interface coming up and down, so let's clear that out. I'm going to go and just do a show IP interface brief. And you can see right now this is pretty much a cleared switch. We've just got VLAN 1 interface, which is currently shut down. I go down and I can see I've got interface Fast Ethernet 0/11 and 12, which are currently up because those are my hosts that are assigned to the VLAN. This is the same switch that we were using before for the router on the stick. But this time, we won't be using the router on a stick. I'm going to go into global config mode and type in interface VLAN 10. Poof. Just like that, I've created SVI10 or interface VLAN 10. I'll do an IP address of 10.1.10.1, which I believe 10.1.10.1, correct, was the IP address I have planned on assigning it. 255.255.255.0. I usually do a no shutdown just to make sure it's up. I'll also do interface VLAN 20. IP address 10.1.20.1. No shut. Shouldn't be necessary just because of that status message saying it's up, but just to be safe, I'll do a no shut. Now I'll go back and do a show IP interface brief one more time, hit enter, and now you can see these two mystical interfaces have appeared, as I was mentioning. VLAN 10 and 20 are now existing on the switch. Every host that's assigned to VLAN 10 can reach this one, and every host in VLAN 20 can reach this one, which are my two hosts I said before. The other key piece of turning on layer 3 switching or multi-layer switching is to go into global config mode and type in the command IP routing. I forget that all the time because if you don't do that, it's just going to say, oh, okay, those are two interfaces, but I'm not going to route between them. On a router, that command is in there by default. On a switch, if you want to turn on layer 3 switching, you need to enable it. So now I should be able to bring up my command prompt, and let me move that into the window. Maybe scrunch it down a little bit. And I'm going to do a ping 10.1.10.1, which, right, is not responding. Let me just make sure my ARP, oh, good old Windows Vista, locking me out of clearing my ARP table. Let me just do a ARP-A, which prints my MAC address table. Looks like I have an IP. Oh, wait a sec. I'm 10.20. Okay, there we go. That is the switch responding. As of right now, I'm not too sure why 10.1.10 is not responding. Oh, right then. You saw it here first, folks. That was, I'm guessing that maybe just I got too impatient and killed it after the, before the first ping could even come back. But nonetheless, it's working right now. So we've got 10.1.20.1, 10.1.10.1, which is the two VLAN interfaces I just created on the switch right here. And now let me just do the trace route. Let me do traceroute-D to 10.1.10.50, which is now reaching the Dell laptop I have connected over there in the separate VLAN. And let me just make sure we're all on the same page. I'm sitting in VLAN 20 right here, pinging into the switch through the switch virtual interface and reaching the host over here in VLAN 10. So that is the layer 3 switching that is happening inside of that switch. The other way I can turn on multi-layer switching is by using routed ports. You can see that as my second part of my setup. Optional, I can create routed ports, meaning any interface, physical interface, I should say, of the switch can be turned into a routed port. Let me demonstrate. I'm sitting on this switch right now on Fast Ethernet 0/24, and right now it's a switch port. It's connected to an uplinked router, and I want to change that over into a routed port and give it an IP address to where, and see if you can follow, this switch becomes a router with a Fast Ethernet interface. It just becomes like any other router at that point, at least on that one Fast Ethernet 0/24 port. Let me show you how it works, and then maybe it'll be a little clearer. Bring up my Terra term. I'm going to go into Fast Ethernet 0/24 and just type the command no switch port. As soon as I do that, I turn off the switching capability on this interface, and I turn on the routing features. Now I'm going to assign it the IP address 10.1.24.1/30. So I'll say IP address 10.1.24.1. 255.255.255.255.2. Now I want to add a side note. That doesn't change the physical characteristics of the port, meaning I don't need like a crossover cable now to connect two routers back to back. But that's essentially how it acts. It's almost as if you had a crossover between two different devices. Now, this, I should mention, this router over here is the .2 of the /30 subnet. So let's see if I can ping it. I'll do ping 10.1.24.2. Enter. Voila. We have 5 now successful pings over to that router. And that router, by the way, is running EIGRP and connects off to the internet. So check this out. Look at this third step. Optional, enable routing protocols. On a switch? No, it's not a switch anymore. It's a router. Matter of fact, hostname, swouter, because that's really what it's become. It's a switch and a router all at once. So I'm going to go into router EIGRP 1, which is the same autonomous system as the router over there. Do a no auto summary and network 10.0.0.0, which will run it for all the 10 network. Now that will actually form a neighbor relationship with the router. I'll do a show IP EIGRP neighbor. And sure enough, look at that. We have our first neighbor that's come up over fast Ethernet 0/24. Do a show IP route. Amazing. Look at that. You see that? I actually am learning routes on a switch. No, a swouter. That's learning about just, these are just a couple loopback interfaces I created over on that router. So it looks like it has more interfaces. And this is the default route that I'm advertising in from the internet. So this switch should now be able to reach the internet through that router. So amazing. I mean, it really is a swouter because we have full routing capabilities. I'm running routing protocols. I'm running virtual interfaces. I'm routing between VLANs, all within a switch. And yet, I haven't yet told you what the best benefit of doing this is. To do that, I have to enlist a few friends of mine to help. There's a little story behind this, as you can imagine. When I first got married to my wife, we found out that we were two very different people, as most people who get married find out. She is a dog person, and I am a cat person. And she had this little dog that's a Lhasa Apso. It's one of those dogs that's kind of like the one you see on the screen there, kind of thinks it owns the world, has the attitude of like, I'm a little princess, don't mess with me. And the dog and I just didn't get along. So anyway, after a few months of, marital conversations about the dog, we sort of, just disagreed on the whole dog thing, on how this dog should be treated and disciplined and all of that, because it barks all the time. So anyhow, let's imagine. Now this is where the real reality breaks off into my imagination. Imagine that my wife, Sue, went ahead and went to the President of the United States and said, this is the little track here, up to the President of the United States and said, Mr. President, my husband and I are just disputing about this dog. It barks all the time. I think that gentle love is the best way to discipline, and he thinks just abuse, beating the dog is the best way to discipline. And I need to protect this dog from my husband. Can you pass a law, please, that will say this dog has the same rights as humans, and we can take care of that, and just make sure everything's okay. President of the United States looks at the bill and is like, why, yes, I think that's great. I have a dog of my own, and I think it should be protected. So the president puts his stamp of approval on it, and the bill becomes a law. This is the law over here. The Lhasa Apso still has now the same rights as humans. I say still. It does. It really does in our home. But anyway, so the president looks at this, and the president says, I can see where this is going. Right now, she's coming for a Lhasa Apso, but there's other breeds. I mean, there's bulldogs and golden retrievers and poodles, and I mean, tell you what, because I don't want to be bothered with all this hassle of all these dogs getting same rights as human, I'll just pass this down to my secretary and say, if you get any future bills from Susan about the rights of any breed of dog, just go ahead and put my stamp of approval on it, the golden seal, and that will become law. That's fine. So same thing happens. She comes in with the golden retriever, much less bureaucratics, and just cut straight through, and we have all these laws for all the dogs. You might be wondering, what on earth does this have to do with anything switching? Here's the deal. The President of the United States is really the router inside of the switch. The dog over here represents one host, a PC, and the law represents yet another host, we'll say a server. The secretary is the missing piece in this whole discussion. We haven't talked about it. We'll call this Mrs. Seth for now. Okay? Here's the idea. When the very first packet goes from one host on one VLAN to another host in another VLAN, or some other route. Maybe it's a router, maybe it's the internet, maybe it's a server, maybe it's a printer, could be anything. That first packet is going to go to the router inside of the switch, which, even though it's all dressed up in this beautiful switch chassis, it's still a router. It's still slow. There's a lot of bureaucratics that goes on inside of that router. It's software based and so on. But the key is once one packet has hit that router, the router passes it down to the switch side, or you could call it Mrs. Sif or Seth. You could call it Mrs. ASICs. You could call her a lot of things. But that is the hardware piece of the switch. So all future packets fly through without having to be checked by the router, because that is known as multi-layer switching. Now, a lot of people, you see the title of this slide, Understanding Layer 3 versus Multi-Layer Switching. A lot of people just kind of use those interchangeably. I do. You know, I'm one of those people. I'm like, oh, it's a multi-layer switch. Oh, I mean a Layer 3 switch. Oh, what's the difference? Technically speaking, a Layer 3 switch is a switch with a router inside. That's it. It's a switch that can do routing. It's got the president. A multi-layer switch is a switch that has the ability to cache route information. That is Mrs. Seth down here. Now, let me say this. Here's the fact of the day. Every layer 3 switch is also a multi-layer switch. But not every multi-layer switch is really a layer 3 switch. Did you follow that? Not every multi-layer switch is really a layer 3 switch. What that means is not every switch has a router inside, which leads to a network architecture that could look like this. Maybe you have a couple layer 3 switches, distribution layer, big pricey switches, and then at the lower layer you have all these multi-layer switches, things that can cache the information, meaning remember what the router told it, but it can't do routing on its own. So here's the deal. You've got one PC represented by the Lhasa Apso over there, and another server over here represented by the law. The very first packet has to go up here and to the router component of the distribution layer switch, and the router sees, oh, I need to cross over here, I need to pass it down here, we're into the switching piece, and we hit the server. And then from there on out, maybe this is on one VLAN, this is on another, all future packets from that host to that server can just pass through the layer 2 engine, if you will, or just be Cephed across the way. Now, we're going to talk a lot in the next video about how that works and the technology behind Ceph, but that is a big piece of why using those switches like we just did, we set up those layer 3 interfaces, is so much better than just using a router on a stick. And that is the foundation of routing between VLANs, inter-VLAN routing extraordinaire. What we saw was, first off, the famous router on a stick. It truly is famous. It has been around for eons. I think they've even passed it down to the CCNA level now as a way to move between VLANs. Then we stepped into the advantages of using multi-layer switches, some of which I just talked about and others we talked about beforehand, using those switch virtual interfaces. And finally, we walked through the configuration of multi-layer switching. Two methods: switch virtual interfaces, which are those logical interfaces that can be reached by any port assigned to the VLAN, and then the routed port, which is enabled by using that no switch port command and literally turns that port of your switch into a router. I hope this has been informative for you, and I'd like to thank you for viewing.